And I'll mute that broadcast. All right, so families. What are families? This was this concept was presented at the beginning of the course. A Revit family is a group of elements with a common set of parameters. Parameter is also called a properties, and they have a very similar graphical representation. To take, for example, a single flush door. This is a representation of multiple elements that have the same representation in floor plan, elevation, and section. And a single flush door, it's a family that is made of multiple types. A type is a member of a family. These are all the parameters of a typical family. Height, width, material, thickness, frame, panel material, glass material if applicable, and that's a common set of parameters. That is a family. And then the different values for the different parameters generate the members of a family. That's called a type. So a family can have multiple types, and the type is usually named after some of the physical characteristics of the element. For example, in a single door family, you have a door that is 32 by 84, 36 by 84, 6 by 5. So the different values of the different parameters generate different family types, but the number and quantity of parameters is the same, and then the graphic representation of it is also the same. So a family is a collection of elements of the same parameters and the same behaviors. There are three types of families. I think you know this already. System families are families that are out of the box, that are predefined in a project. You cannot save them as an external file. Examples are walls, floor, roof, stairs, ceiling dimensions, views, etc. You can copy paste them between projects, but you cannot save them as an external file. And then component families are loadable representations of geometry that are saved in the extension .rfa. RFA stands for Revit family. And those are typically the components or the files inside a library of components. And that includes your doors, windows, casework, fixture, furniture, planting, etc. These component families are brought into the project as an external files using the load family button. And then the other family that we didn't talk too much are in-place families. And these are families that are built on the fly. These are families that are very unique. So you build them on spot without the need of opening the family editor. And so in-place families are they are rarely used, but they are typically, you only use them when you want to have like a very unique representation of an element. For example, a very unique lobby desk, or a very unique type of lamp, for example. And If that element is unique in the project, then that's a candidate to do an in-place family. In-place families cannot be saved as external file. They live inside a project. An in-place family only one in-place family can exist at a time, meaning that if you copy an in-place family, it generates another family. And so that's why I say it's a unique element. When we get started in creating a family, we need to choose the right family template. And a family template, it's a placeholder file that has the appropriate parameters associated with the category of that object. For every category in Revit, there is a different Revit family template. So you have case-work template, baluster templates, entourage templates, profile templates, structural templates, column templates. And the template, it's predefined the type of built-in categories that are part of the, that defines the category of an object. So when we get started in Revit, we have to pick the appropriate Revit family template. If you are creating a new family from scratch and you don't find the appropriate template, the best one you can use is this one called generic model. Notice also that the generic model template comes with different flavors.
Caesar, can I stop?
Yeah. Yes.
Sharing your screen or no?
Oh, am I not sharing?
No.
Oh, my bad. Sorry, guys. Thanks for letting me know. Okay. Thanks, Romeo. Okay, so I was, these are the three types of families that I was talking about: system families, component families, and in-place families. And these are the different family templates that ships out of Revit. And then I was saying that the generic model template comes in different flavors, and the different templates respond to the different ways in which a family is hosted. So when you build a family, you have the option to make it be hosted by something else. It could be hosted by a wall. For example, door, it's a wall-based family. It needs a wall in order to exist. Another example is, for example, a wall sconce or a fire extinguisher, a cabinet. All those are wall-based families. You also have roof-based families hosted by the roof, for example, skylights or mechanical equipment. Line-based families are families that grow given the extension of a line. So examples of line-based families are, sometimes you can create these arrows, like represent a graphical representation of an arrow in 3D, and then each end has a handle, and you can just push the end of those arrows, and you can have different instances with different sizes. Another example of a line-based family is casework, or the hard material, the countertops. And countertops sometimes are created line-based, and what that means is that what defines the extent of the countertop is the size of this line, and this line has a handle, and you can just push forward and change the size of the casework extent. Can be hosted by a floor, for example, a table, a chair, or any type of furniture. It can be phase-based, and when it's phase-based, it's not category-specific. It's just snap to any geometry existing in the model, or it could be ceiling-based, like lighting fixtures or exhausts or etc. These are the different tools for editing and creating family. These are the tools available in the family editor. We're going to jump into that. When we create a family inside Revit and we open the family editor, we're actually presented with a different way of modeling. This is a solid massing tools. And so this way of modeling using solid geometry is not available on the project environment. It's only available in the family environment. And these are solid representations, and you can create all these different type of shapes or called forms. And so an extrusion is a profile extruded along a direction. A solid blend is an extrusion between two profiles. Revolve, it's a profile that revolves around an axis. You can define the start angle and the end angle. If the whole angle is 360 degrees, it creates a whole a complete solid object. You have a sweep. A sweep is a profile that is extruded along a three-dimensional path. That path can be in 2D or in 3D. And a solid swept blend is two profiles merge along a path. I'm going to jump into this a little bit. So just as you do solid massings, in Revit, you also have the ability to create voids. A void is the opposite of a solid. When a void intersects a solid, it carves the solid. So voids are used to create negative or to subtract portions of the solid geometry. This is an example of a void. This is a void extrusion. When the void intersects the cube, it carves part of that. And it has the same logic as the solid, it's just in the negative space. A void blend, extrusion between two profiles. A solid revolve, it's an extrusion. It's a revolve, it's an extrusion around an axis. A void sweep, it's a profile along a three-dimensional path. And a void swept blend, two profiles blended along a path. And then by using this combination of solids and voids, you can basically model anything in Revit. Let me pull an example, and this example is already available to you. I don't know if somebody called in late, maybe Urmila. I'm gonna copy paste again the data sets in the chat panel for whoever arrived late.
Thanks, Caesar. That'll be helpful.
Yeah. And so in the folder I gave you, there is all these different type of families. I want you to look. Just open. Let's start by opening this family called toaster. This is a family that is floor-based. The reason I know is because this is a placeholder of a floor. And when this family was created, it started with a generic model floor-based template, which provides this placeholder floor that allow you to snap the family into a floor. This floor, by the way, it doesn't travel into the project. This is just a representation of the floor that is used by the geometry to indicate what is the face this snap to. This is a highly detailed family. Maybe I can disable this. Yeah. If you look at this, it's this is all made of these are all solid-based objects. So this is the result of all the solid editing tools. And it's fascinating to me to do some reverse engineer on how this was put together. For example, you see this is the handle. I'm in the family editor. It's a sweep. How do I know? When I select it, it activates the modify sweep parameter. What is a sweep? The sweep is a profile along a path. When I edit the sweep using the edit sweep, that's how it was created. This is a profile. The profile is hosted by a reference plane. And then this is the path. And so when the profile travel along the path, it does a complete loop and it generates that object. Let's see how this button is created. This is an extrusion. You can see it's an extrusion because in the, let me start my submit. When I select this button, it says an extrusion here, right? And when I edit the extrusion, then I understand the logic behind it. It is a loop hosted by a reference plane, and it has these dimensions. It starts at minus -1/4 of an inch, and it finishes almost at 0. So the start and end of the extrusion is relative to the reference plane. Let's see how the body of this was created. When you select it as an extrusion, you edit the extrusion, and it is a simple extrusion. This is just a shape that is extruded 1/2 inch. Want to see what the bread is done? I mean, I can select this. I can isolate it. So this piece of bread, tilted piece of bread, is a simple extrusion. You edit the extrusion. That is the shape of the extrusion. It has a 3/4 of an inch thickness. And then to make it look and render nice, it has a material. And the material is toasted bread. And this is a custom material, toasted bread, that has this texture and this appearance. This overlay, it's this finish bump. Reset temporary. So this is a very well detailed family, and I'm not advocating you to do this kind of detail level family because this is actually not good for a Revit project. In reality, you know, if you're doing construction documentation, a representation of a toaster might as well just be a simple box. But I think this does raise the question that before you attempt to create a component, you need to ask why. What is the purpose of the family? If it's going to be just for construction documentation, maybe it doesn't need to have all this level of resolution information. If it needs to be used in a commercial or in a rendering, for example, then you probably need this level of resolution. If the family is going to only be displayed in floor plans, and you're not going to coordinate with any consultant or extract any volumetrical information, the family might as well just be 2D. And this actually might help there's a lot of examples of clients that use two-dimensional families to do uh, to do some space planning. And then when they select the final one, then they convert it in 3D. So understand the purpose of a family helps you guide the extent of the effort needed to create a family. This particular family, this toaster, I don't know. I want to guess it take about 2 or 3 hours to build. And this is knowing that you have all the right information and that you have a process, etc. Whereas a simple box for documentation will take minutes to build. And so what's going to be the purpose is a big driver. Let me close this and show you other highly detailed families. I mean, these are fun to watch. These are great examples of the full use of the modeling capabilities, solid modeling capability. The other family I want you to open is this wall. No, it's the Tiffany lighting. You're not going to find this family out of the box. But this is probably used in historic preservation. It's has this classic old Victorian feeling. This lighting fixture is made of families inside other families. For example, this is the concept of a nesting family. When you select, if you select this, notice that this is an extrusion. I'm going to edit the extrusion. And I was trying to find the profiles, but they are probably small. Edit the extrusion. Probably behind this. I can find it to some extent. I can find the profiles here. Let me try another example. Let's try this body. This is like a model inside another model. So this family was edited, was brought into the family as a nested family. So nesting family is a very common process when creating complex families. If a family is going to have multiple components and those components needs to be expressed or quantified, sometimes it's a good idea to nest a family inside another family. So I'm opening the nested family here, and this is the actual glass. This guy, I know this guy, Michael Terminello. He is an incredible family editor. He actually published a book teaching a book that's about 3 inches about how to do all this. He didn't do any money and stopped publishing, but this book was very popular in 2016, 2017. Again, these are plain extrusions. And then these extrusions are, there you go. It's a profile with a thickness and a specific material. The material is being set up to have this realistic bump custom created. Again, and then each of them is hosted by a work plane. I think the challenge here is to have all the work planes in place. Beautiful family. Is that family then is brought into this one. where you add these lighting source. The lighting source have map photogrammetry distribution embedded that make it shine in a very specific pattern. I also want to show you, there's another family here, the blackjack table. This is a family made of nested components. And this guy was actually hired by casinos in Vegas, or he was working for a firm that does casinos in Vegas. And they didn't care. I mean, they love to have all these highly photorealistic renderings from Revit. They paid this guy a huge amount of sum of money to model a specific model and type of furniture. This is a blackjack table. This guy went to the extent of modeling every single chip. Words here were individually carved. This is actually model text with a very tiny thickness. And the chairs are nested families that were brought from outside. You can open this family and try to understand how it's put together. These are all extrusions, revolves. I'm going to edit this family. And when I pick all these components, this is a revolve. When I edit the revolve, it's a profile extruded along an axis. So you build the axis in 3D, you build a profile, assign it with a finish. The finish is wood oak dock, wood oak 3. And then this family is brought into the blackjack table, etc. And so all these elements are individually modeled. Now, to get to this level of modeling, you really need to understand, how the solid modeler works. And that comes with a lot of experience. I am going to do a very simple family so that we can all move at the same pace and I'm able to finish by 7. So we're going to create a base cabinet that is wall hosted and that is parametric and it has 2 doors. I think with that, we can get to 7 o'clock with no problem. But there's a lot to learn about solid modeling editor and a lot of tricks that I am not going to be able to address. I mean, this is fundamentals. I could easily just teach an entire class about families if we want to get to this level. But I think this challenges the notion. I mean, a lot of people say, oh, no, in Revit, you cannot model. You cannot do fluid modeling because it's very rigid. And it's impossible to do the kind of things you do in Rhino, for example. And I actually challenge that notion. I think if you have the know-how and you understand how to properly apply the different modeling technique in Revit, you can basically model basically anything. And I've seen very complex type of projects expressing family components in Revit that test and challenge the assumption that you cannot do free modeling or free form modeling in Revit. Okay, feel free to play with the rest of the families. There's other ones here that are nice to watch, like the, I think there's a pool table that I mean, at some point I needed to model a sphere that is carved with a text, a model text. And this is amazing. It's a very simple family, but it's amazing how it was done. I'm going to edit the family so you can see it. It's a face-based family. It is a revolve, and I edit the revolve. The color, the orange color, it's this profile, exterior 360 degrees. The white part, it's also a revolve, but it's only those two pieces, you see. And it revolves 360 degrees with a different color. The cap, this is actually 3D text. That is three-dimensional text, but is cut by this void sphere. And so it makes the text follow the curvature of the sphere. So you see this is a void with a thickness, and is intersecting this three-dimensional text. It's cutting it. It's making it look perfectly curved, aligned with the surface. Very nice done. And again, it's just a matter of finding the technique to make it model correctly. For those who do like historic preservation, and you have a model like pieces of building that are on plaster or on wood, this is an example of how you could do that using just solid modelers. And this is a lot of voids intersecting solids. Okay, so let's do something that is very simple. We're going to create a cabinet, and I'm going to walk you through the steps very quickly. Here are the full list of steps. So we started by picking the right family category, selecting the appropriate template. Then we build this, we need to think, what is this family going to use for? And so this is going to define the extent of your effort in the modeling process. You can, the family can be very simple because it may not be visible. It's small enough that it's not visible at certain scales. Or it needs to be super detailed because it's going to be used for rendering. So defining what is going to use it, what is going to use it for is going to define the objective of the family. Then from there, you create reference planes. The reference planes are like the skeleton of a family. It's the part of the model that make it parametric. When a family stretches in size or stretches in different directions, it's the result of these reference planes being moved by dimensional parameters. And so we build a skeleton of a family. We associate and build dimensional parameters that will flex the family. Flex a family means testing the parametric properties of a family, making sure that it's changing in every direction. Then you build additional parameters, assign visibility settings, define family types, and load it into the project. I'm going to go one by one on these steps as we go into our exercise. So on Revit, close any file you have open, and let's create a new family. And we're going to use the furniture templates. So open the English Imperial folder. And let me know if you don't have these templates. If these templates are missing in your installation, that means we need to go get them. Is anyone missing the family templates? Again, you just go family new, and you should have English Imperial. We okay?
Yep.
Awesome. All right, so in here, in the family templates under English Imperial, we're going to pick the furniture. This is the family editor. And check it out, it's a new user interface. Like, these tools are different from the project ones. Here are your different ways of modeling solids. You can model solids, you can also model voids. This is important, ways to create reference planes. It also has something called a reference line. A reference line, it's a also help me anchor certain geometry to alternate to an alternate collection of reference plane. Notice also that the family editor comes with two reference planes that intersect. The intersection of these two reference planes is the origin of the family. So when you click on this reference plane, they have a nomenclature. This is the center from back, meaning this is the center of the family, this is the front, and this is the back. When you select the other one, the name of this is center, left, right. So it's defining this is the right and this is the left. And when you select the reference plane, notice that there is a checkbox that says define origin. You can only have one vertical reference plane that define an origin and one horizontal reference planes that define an origin. And then the intersection of these two reference planes, that is the origin of the family. The origin of the family is important because when you drag and drop this family into the project, the cursor is snapped to this origin point. So whenever you click in the project, that's the point in which the family will be dropped. And so also notice there are all these different views. There are floor plans, ceiling plans, 3D views, elevations. These are ways to change and modify elements. But we're going to create a cabinet. And so in a nutshell, let me sketch what we want to do. We want to create a wall cabinet. So it's a simple box. This cabinet needs to be able to flex. It needs to have a depth. It needs to have a height. And it needs to have a width. I also need the cabinet to be wall hosted. So it's going to be hosted by a wall or by a face, or a face. And then I need to add a door that in projection has a swing representation as these, and maybe two handles. And then this wall cabinet needs to be able to generate different family types assigned to the different parameter values. So I can have a 36 cabinet, 24, 18, etc. That's the goal. And this is very common. This is used in kitchen representation, or I also need to assign a material. The material of the cabinet needs to be the same material as the doors. And when I flex the family, all these parameters need to adjust accordingly. All right, so in order to create this representation, I also need to decide what's going to be the insertion point. And when I build this type of, think about the user. What's the user experience of a family? So if a user is going to be creating, rows of or an array of cabinets, maybe the insertion point of the cabinet should be like that. So you click this point, then you click this point, you click this point, and then the user is just generating this row of wall cabinets. Or if you think it needs to be the center, then it could be the insertion point could be at the back. I'm going to use the latter. But again, we are designing a family. We're designing the user experience. So I'm going to decide that my cabinet is going to be centered in the back. This is the front, this is the back. And I need the skeleton of the family to have a reference plane here, a reference plane here. And then I need to create the parameters, the depth, the width, and the height in a different elevation. So going back to my recipe, this is my recipe of creating families. I picked the right template. Now I'm here. Number 2, create and name reference planes. Let's go here. Create reference plane. Reference plane is under the datum objects.
Did you stop sharing your screen?
No, I don't know what happened. Is it there? You guys see me?
I see it.
I don't know what happened.
I can see it.
Do you see it, Ruth?
No, but I think I've been shifting computers, so maybe that's the problem.
Okay. Well, let me know if you need me to repeat anything, Ruth. This is the these are the reference planes that indicate the origin of the family. I'm going to add a reference plane. The shortcut for the reference plane is RP, so you can just type RP, reference plane. I'm going to create a reference plane from the bottom up, and another one here from the bottom up. Okay, first thing to understand, the direction in which you create a reference plane is going to determine the direction of the extrusion that are hosted through it. What do I mean then? When I created this reference plane, this was my point 1 and this was my point 2. And so this is a plane, a 2-dimensional plane. And as a plane, it has a direction. There's a positive side and a negative side. So in Revit, the way you build your reference planes dictate what is, and I'm sorry, this is the, yeah, this was my point 1, this was my point 2. And in Revit, the direction that define the positive side is clockwise. So what does that mean? That means that the positive side of an extrusion hosted by this reference plane is going to be here. That's the positive side. And the negative side is going to be here. And this is because this was my point number 1 and this is my point number 2. So it's always follow clockwise direction. And why this is important? Because when you start creating extrusions that are hosted by reference planes, the instance properties are going to say what's the direction and the distance. What is the distance of the extrusion? And the distance of the extrusion can be a positive number or a negative number. And so keep in mind that you know, sometimes depending on how the work plane was created, this could be negative or positive. There's nothing wrong about it. Just understand the logic behind it. Okay, so reference planes also define, you need to be assigned with a name in order to be identified as a work plane. So to add a name to a reference plane, you can just click where it says click to name here. And this is going to be my right. This is my right side. Click on the other one. This is my left side. And the other ones are already predefined. You don't need to name them. They already come with a name. All right, now I'm going to define the front reference plane. Again, RP reference plane, RP. Select the reference plane, and this is click to name. Let's go with the front. And what I'm doing right now, this is a floor plan view. To define the height of the wall cabinet, I need to switch to the front elevation. You notice that there is a reference level that defines the, you know, the ground level of a family. And I'm going to add on the front elevation another reference plane. And then I'm going to name it height. Top. Let's call it top. That's the top of the cabinet. So the cabinet is going to extend from the reference plane to the top. Now, to make it easier on us, I'm just going to close the 3D view 1. I have the floor, the reference level, the front, and the right. And then I'm going to tile them. WT. Well, WT is wall tile. Let's just create these tiles. And then zoom all to fit. You can just type ZA, and that's going to zoom every window in the tile distribution to the full extent of the geometry. So again, to WTTW. This is what you have. You have the right view, the reference level, and the front view. And then to tile it, just type WT. And then to zoom, extend each of the windows, just type on the fly ZA. So ZA equals zoom all viewports to full extent. And this is true for the family editor or for Revit projects. Okay, so this is the floor plan. And then in the floor plan, I think I have all the working planes that I need to flex. So now it's time to add the dimensional parameters. So that is in my recipe, step number 3. Set dimension between reference planes that will be parametric. Parametric is a value that will change to create different family types. And so the 3 parameters I need to add here is the width, the depth, and the height. So the width and the depth, I'm going to do it in the floor plan, and the height, I'm going to do it in the right elevation. So in the floor plan, I'm going to create a dimension. So go to the Annotate tab, Align a dimension, Annotate tab, Align dimension, and place a dimension string between the reference planes that define the width. Another dimension to the one that's going to represent the depth. And I'm going to jump into the right elevation. And this is the elevation. This is the dimension that represents the height. These are just plain dimensions, nothing fancy about that. Now, a dimension can be converted into a parametric property by converting it into a label. So a label, a label assigns or converts a dimension into a parameter. So let's do the first one. This is the width. You select the dimension, and in the instance parameter where it says modify dimensions, you're going to change the label to a new parameter. You say the new parameter has this calculator with a little star. And I am creating a new parameter. And this is called a family parameter because it's living inside the family environment. Family parameters cannot appear in schedules or tags. So if you need these parameters to be visible in the project in the form of a schedule, then you have to use share parameters. If not, just keep the family parameter. That makes sense. So if the value of these parameters need to translate in Revit in the form of a schedule in the project or in the form of a tag, then you have to use share parameters. And I show you in a previous class how to create share parameters. We're not going to do a share parameters here. I'm going to stick with family parameters. The name of this parameter is width. And then we need to decide, is this parameter a type or an instance? And so I want to generate an array of different family types. So all the parameters I'm going to use here are type. The rest is pre-filled for you. It's a common, it's length, it's not dimensional. You just hit OK. So the only values here is family. The only values I input here is width, and it's a type. Hit OK. This is parameter number 1, width. Let's do the depth. Select the dimension, hit the create parameter, call it depth. Notice that Revit always remember the last input, so moving forward, everything it creates is going to be instance. And hit OK. And then on the height, I'm going to jump into the right view, select the dimension, and convert it into a parameter. The name of the parameter is height. It's a type parameter and it's family parameter. Any question here? Does anybody need me to repeat anything? I have defined 3 parameters in the family. And this family is defining ultimately is going to define the behavior of a geometry. So this.
Sorry, please, a quick question.
Yeah.
You know that the dimension is associated as a type parameter when you get that height equals or something like that. Before that, that's okay. I'm just wondering.
Yeah, here. You were talking about this parameter, the type parameter. Or are you talking about the?
No, when I'm trying to understand, how do you identify, like in the family you have this dimension, how do you know it's associated with, I saw you create it and make it a type parameter, but
okay,
how do you know a dimension line that's associated with a parameter? That's my question.
Yeah. The best answer for you is to check your assumptions by flexing the family. And flexing the family means opening the family type dialog box. Family type is this box with 4 square. I'm going to be using that a lot. Family types. And these family types discloses all the parameters I have created into the project. So these 3 parameters, these are the custom parameters that I created.
Okay.
And these are the values according to the dimension that is there. But I can test it and see if it works. Say I'm going to change the width from 7 feet, which is unreasonable. I want to make this 3 feet. And the height, I'm going to make it 4 feet. And the depth, I'm going to make it 1 feet. And then I hit apply. And you see how the different parameters adjust.
Okay. So that's the way you, if it's been, successfully associated with the pattern. Okay, that makes sense. Thank you.
Now I'm going to undo because look what happens with the width. The width needs to be equally centered to the vertical center reference plane. So I'm going to undo. I need to do one more thing to make sure that the width flexes well. And what I'm trying to say is this is the origin of the family. And whenever I change the width, I want to make sure that these elements remain equal, and equal. So all I need to do is create a dimensional string and then apply the constraint of equal. And then that width, no matter what value it has, is always going to flex relative to the center as opposed to from the first element. I'm going to create another dimensional string, align dimension from the left reference plane, the center reference plane, the right reference plane. I'm going to place it. When you place a dimensional string, it presents you with the opportunity to apply an equal constraint. This is a constraint. And when you click that constraint, it will distribute equally the distance. And that constraint is required to be sure that the width always flexes relative to the center and not from one end. Any question here? Again, the way I place this is dimension, first, second, third, place it, and then equal. If you miss the opportunity of clicking EQ, just go back and select the dimensional string and it's going to show again. That red diagonal, it's an indication that the constraint is not applied. But when you see when this one is applied, the red line, the diagonal red line is no longer there. I'm going to delete the other one and I want to have this relationship be equal. I'm going to move it out. Any other question here? Make this bigger. No, I don't think I need the front view. And just modify, just model it to make this bigger. Okay, so we have the width, we have the height, we have the depth. Let's flex it. Go to the family types. And for the depth, let's change this to 1 feet, for the height 4 feet, and for the width 3 feet, and hit apply. Now notice that the family is reacting to changes in the reference plane, changes in the dimensional constraint. All right. So the process of testing parameter values and applying it to a family, this is called flexing. Flex is tests family with different parameter values. And this is key to the success of a family. We always need to flex. We always need to test the family to make sure that the parametric properties are behaving the way we are expecting, because sometimes when we do that, things are not correctly snapped, or we missed applying a correct constraint, or we snap to a or we assign a parameter to something that wasn't supposed to be. Flexing, it's a quality control activity to make sure that the family works as expected. And we do that all in the family types dialog box. Okay, so I have solved the, I think I have flexed the family. Go back to my recipe. I created dimensional parameters. That was step number 4. And I flexed the family. That's number 5. Let's continue with the recipe. Then it says create 2-dimensional model and symbolic line work. Symbolic line work is are elements of the family that will be visible only in projection. For example, I don't know, there are families that, for example, the diagonals that represent the door swings, that is a symbolic line. It's only visible when you see the door in elevation or in a section, but you actually don't see it in a 3D view, or you don't see it in a rendering. So symbolic line works are 2-dimensional objects that enhance the representation of an object in a specific view. For this cabinet, I don't have a symbolic line work, so I'm gonna skip step number 6 and jump into number 7, which is create the solid or void geometry using the reference planes as the snapping references. Okay, so all I'm going to do is an extrusion, and the extrusion is going to use the intersection of the reference planes, and it's going to have a certain height. So I'm going to do it 2 times. The first one you can watch, and the second one we can do together. So you create an extrusion, you use the rectangular tool, and make sure it snaps to the intersection. This is super important. You see, this is a snapping condition. You see the X, purple, and this dashed line. When we snap to intersections of reference planes, we are creating dimensional relationship with those reference planes. What does that mean? That the geometry is automatically creating a connection with that reference plane. If we don't snap to intersection, then the geometry is just going to be like floating. It doesn't have any relationship. So I'm going to snap to the intersection here. I'm going to snap to the intersection there. You see those locks that appear. This is a manual. This is forcing a dimensional constraint between the sketch line and the reference plane. If we snap to reference planes, we don't have to lock the geometry. In fact, locking the geometry sometimes it over constrains the family. So don't lock don't over constrain the geometry with unnecessary locks. So those locks are not necessary to lock it as long as you snap to the intersections. Okay, then I click the green checkbox here, and you see that a box was created. The extrusion start is 0 from the reference level. This is the reference level, and then 1 foot above reference level is the top of this solid box. In the right elevation, in the right view, I'm going to click on the solid. Now I need to make sure that the height is parametrically snapping to the top of the reference lane. So you grab the handle, drag it up, snap it, and now here I lock it. And the reason I lock it here and not in the intersection is because the relationships between sketch lines and reference planes happen during the creation of the solid. And after the solid is created, those relationships cannot be reestablished unless you edit the extrusion again. And so after the extrusion is created, then the only way to establish this relationship is using locks. So during the process of creating the solid, don't use locks. After the solid is created, lock it. And so grabbing this handle and snapping it to the reference plane, snap the geometry to the top reference plane. And now let's flex it. Go to the family types. All right, I'm going to increase the depth to 1'6". The width, I'm going to increase it to 5. And every time you hit apply, you can see the effect of the new parameter value. And the width 3, height 4, width 1. I'm going to take it back to depth 1, width 3, and height 4. Hit OK. Any question here? This is super simple. This is a super simple family. This is just a box that is parametrically in 3 parameters in 3 sides. What's next? So what's next is to build the doors. And so for the doors, I'm going to create a new reference plane that is offset from the front reference plane. And the easy way to do that is using the create a reference plane by offsetting. To do that, you go to the Create tab, then you hit Reference Plane, and here you pick this guy. Is the line with a green line. This is creating an object by selecting an existing one. And after you click that one, you give it an offset of 1 inch, 0.1. Zoom to the floor plan, and you see the reference plane needs to go to the inside of the cabinet. So it's gonna go, I'm gonna click on the screen when the preview is above the reference plane. And this reference plane, it's representing the thickness of the door. And the thickness of the door, I'm just going to assume is 1 inch. Could be a half an inch. And so the question here, once you're done doing this, click Escape to cancel the creation of reference plane. So creating an object by offsetting is a very quick way to do something very precise at a very precise distance. Now, when I flex the family, I always want the new reference planes to be at an inch away from the front one. So I'm going to create a dimensional lock, a dimensional constraint, and lock it. So this is what I'm going to do. Go to the Create tab, or Annotate tab, create a dimension, place the dimension, and lock it. And what this is doing is that no matter how I flex this family, this reference plane is always going to be an inch away from the exterior. And the way to test it is by assigning different depth. So let's assign this is 1.6, apply. Notice how the 1 inch relationship is preserved. 2 feet, 1 feet. Again, the way I did that, go to Annotate tab, align dimension, and after you place it, you see this lock, you lock it. If you miss the lock, go back and select the dimension and lock it again. You don't want to have too many dimensions locked at the same time. You know, when I lock this, I have 2 constraints doing the same thing. This is over-constraining the sketch. Revit is going to be unhappy when you twist the arm 2 times. So just twist it 1 time. There's no need to force Revit to do things twice. Okay. And now what I'm going to do next is to open the space for the door families. And so select the cabinet and the floor plan, grab the handle associated with the front. I'm going to snap it to the new reference plane I just created and lock it. And the reason I'm doing that is that I'm going to bring a family of doors, and that family of doors, I'm opening space for the doors. Any question here? You want me to repeat anything? All right, now let's flex it. Open the family types and change depth values for different. I'll change this to 2. Perfect. This is working as intended. 1 feet, 1'6". Okay, so this cabinet is going to have a single door. I'm going to switch to the front elevation, here. And what I need to do is to create a family that brings a door. The door can have a glass or not. I'm looking at the clock. I'm probably not going to have time to model it with a glass, but you can do it that way. And then it needs to have a 2-dimensional line that represents the swing and a handle. Now, I have created that family for you already. And so in the files that I send over, open the file called door. You go File, Open, We'll try it. Here's one that's called door, and hit open. I didn't ask you to create this because it's basically the same process. This is a family genetic model. No, it's part of the casework. It has a width, it has a height, it has an equal representation. It has a thickness. Let's see, this door. And the only problem with this door is that it is. Oh, that's fine. It's looking correct. Let's look at it in 3D. Yeah, the thickness is incorrect. We need the thickness of the door to be 1 inch. It says this constraint somewhere is a constraint. Let me open the floor plan. Yeah, so what I need to do is open the door family. Notice in the floor, in the front view, how there is an extrusion that it's 4 feet high. You're gonna select that and change this to 1 inch. And then go back to the reference plane. Go back to the front elevation. That is 1 inch. Go to the floor plan. Wait, what did I just did here? My bad. What undo? I know what I did here. I'm confused. I have the two families open, and this is not the door. So I jump in the wrong family. My bad. I'm going to. Sorry, I was confused here by something I shouldn't have done. This is the cabinet. So I'm going to save it. The cabinet, I'm going to save it as the wall cabinet. And then the door is, I'm going to close this family because I'm getting confused by two families open at the same time. So here's the door. Okay, this is the door, and this is the cabinet. All right, and this guy has 1 inch. Yeah, so the door was perfect. There was nothing wrong with the door. The door is ready to be inserted. So excuse me for that. So in the cabinet, I'm going to close the door family and open just the cabinet. Switch to the floor plan, or switch to the switch to the front view of the cabinet. This is the shape of the door, and I'm going to load the door here. Now, the door is going to attempt to come align with the reference level, right? It's going to come flat to the floor, and to force the door to align with a reference plane, I need to activate a reference plane. So this is the front reference plane. these reference planes that is behind it, I'm in the cabinet, wall cabinet file. The second reference plane, I'm going to change, I'm going to give it a name. This is going to be the, I'm going to call it the door plane. Is the door. So the front, the door, then save the family. And I'm going to load the door. But I need in order the door to align in the proper location, this needs to be my active work plane. You know, the work plane that is called door needs to be the active work plane so that the door align with this reference plane. I don't want the door to be sitting on the floor. I actually want the door to be in the front of the cabinet. And to force that door to be at the front of the cabinet, the active work plane needs to be the door work plane. So I'm going to switch to the front elevation. Then in the front elevation, under the Create tab, I'm going to set my working plane. I'm just defining what is the surface the door is going to snap to. In the work plane, I'm going to pick the door reference plane. You want to see it, that's the work plane. And now I can bring the family. Insert. Load family. Navigate to the door. Here's the door. The door is loaded in the project browser. And I just drag it and drop it. And notice how this is a face-based family. So it will automatically detect the face of the cabinet. Any question here? You want me to review anything? What I did is I'm in the cabinet file. Then I brought the door and I snapped the door to the face of the, this is what we have now. This is the cabinet, this is the front of a cabinet, and the door is snapped to the face of the cabinet. Now I need to make sure that the size of the door is the same size as the cabinet. And here is a concept of associative dimensions. So this door is a nested family in this family. And the type parameters of these can be associated with these active family parameters. In other words, what I'm going to attempt to do is that the width of the door matches the width of the panel, and that the height of the door matches the height of the cabinet. In building that connection, bridging that connection, it's called the associative parameters. And how you do that? I select the door, I edit the type properties, and then these are the the width and the height, properties of the door. And so to make the connection, I click on these buttons here, these toggle buttons. This is associative parameter. So by clicking these buttons, I can connect the value of the door type properties to the family type properties. And so the type properties of the width type properties of the door equal to the cabinet width property, and the height of the door equal to the height of the cabinet. So notice how the values of the door are now grayed out. That means that they are inheriting the value of the cabinet parameters. So here is the door has exactly the same size. We can flex it to test it. So flex. If the cabinet has a height of 5, the door has a height of 5. If the cabinet has a width of 2, the door has a size of 2. Now, the only thing is missing to finalize this is to lock the door in the right position. And I have to do it in the X and the Y. And I use the align command to do that. I'm going to align it in the X direction, and I'm going to align and lock it. And then I'm going to align it in the Y direction and lock it. So align in the X, align to this reference plane, the face of this door, and lock it. And then align to the reference level, the bottom of the door, and lock it. And then here it goes. Notice how the symbolic line don't appear in 3D. Symbolic line only appear in projection views. And we'll do a final flex. So we said if the width is changing to 3, the door changes to 3. If the height changes to 3, the door height changes to 3. And so this concept of nesting a parameter inside another one, and then associating the type values using the associative toggles, is an excellent way to build smart families. You don't have to individually create all these additional parameters to drive the parameters of the door. I mean, the door is a nested family with embedded parameters, and those parameters are connected to the host. You just change the parameter of the host, and then the nest family changes parameter as well. And then the last thing I'm going to do is the material. So the extrusion of this extrusion, I can associate to a material. Say the material for the cabinet needs to be wood. So I'm going to go find a wood cabinet or a wood material. I don't have any in the project, but I can quickly create one. If you remember, I start with the default. I duplicate the material with assets. Call this wood. And then I go to the asset library, go to the appearance library, find some wood that you like, the birch wood. And then hit apply. In the graphics, use the render appearance to make it look that color, hit OK. Now the cabinet has this color. What happened with the door? Same thing. The same way I connected the type parameters, the dimensional type parameters, I can also connect the material parameters of the door. So this is the family of the door. When I access the type parameters, you see there's a door material. I use the associative parameter toggle to connect it to the, oh, I think I need to build it here. No, in this case, I'm not going to be able to, I don't have that, but I can just assign it here directly. I mean, I can connect it, but I need to build, the parameter as a type parameter. I don't have it. I'm just going to use wood here. Now these two materials have the same one. And then the last step is to create different types. Now that I have flexed it, now that I know it's working, I just create the different family types. So to create a family type, go into the family type dialog box, hit new type, and just give it a name. This is a 3 cabinet by 3 by 3 by 1 with height depth. With height depth. And I create another type parameter, another type. This will be 3 by 4 by 1. 3 by 4 by 1. Apply. I'll create another one. This cabinet is going to be 2 feet by 2 feet by 3 feet by 1. So width is 2 by 3. There's another one. This new type is going to be, I don't know, 1 feet by 3 feet by 1. And the names are textual references. So this is width 1, height 3, and width 1. So I have all these different types. I have 4 types. I can continue building more values. And when this is ready, I just test it in the project. I want to save this family, create a new project. Using the architectural template or and I'm going to load this family into the project. Load into the project. Place it. Let's switch to a 3D view. This is the project. And I can have multiple different types. This is the 1 by 3. Give it some color. This is the 2 by 3. This is the 3 by 3 by 1. And this is the 3 by 4 by 1. I can create new types in the project if I need to. Remember, edit the type, duplicate, and I say, okay, I actually need one that is 4 feet by 3 feet by 2 feet. So width is 4 by 3 by 2. I just created a new type in the context of the project. It's a big cabinet here. And types can be built in the project or they can be built in the family. So that is, that closes the recipe here, which means that you flex the family, you create new types, flex the family again, load the family into a project, and verify that the family works in different views in the context of a project. All right, so simple family, one nested component with associative parameters, same material. There is certainly more families that I can teach you that are more complex. But this just gave you the surface, just a scratch of what the families, how create a family looks like. Okay, it's 7:15. Any question? So I'm going to stop the